Okay, hi everyone. Welcome to another Wolfram language design review, looking at a variety of different functions, part of our incremental language development series. All right, first up, HumanEvaluate. It's a function we thought about like 15 years ago, and right. Okay. That I bet I have notes on this from like at least a decade ago. See if I can find them.
Yeah, I tried scanning through the design notebooks I have, and it probably predates those. I wasn't sure if HumanEvaluate would be like a Mechanical Turk sort of situation, or if this is a subset of reinforced learning from human feedback.
Well, this is a, yeah, I mean, it's a somehow, actually interesting. Maybe I called it human compute before. Oh yeah, 2015. There we go. Decade wasn't too far off. Okay, let me see what I've got here. See what I have. Meeting with Carlo, Ricardo, and others about the roadmap, 2015. Okay. Let me just see. Oh boy, the file system has a lot of these. And they're all in how very confusing. Oh, here we go. Project accumulator post. Okay, there have been some summer school projects related to this. I'm looking through. Sorry, there's mostly things that are, yeah, I probably should have figured this out beforehand. Boy, something I should in my there's a lot of things in my file system which are currently only showing up as dead cache hits. Just a minute. Tons of entries, sorry. All right. Okay, we will be, let's just see, I'm sure I can find, I mean, it's clear that there was text about this previously. Oh gosh,
Okay.
what the heck? I mean, hold on one second. I think I'll be able to find it. I hope I'll be able to find it here. Just endless things called old files, but there was a one here. Okay, let's see if I can find this. Oh, see, background material / human compute. Okay, this was from the 2018 summer school list of, look at this. Oh boy, that one could be done well, better now. Responder bot for spam phone calls. Let's see, background material, human compute. So let me just go find that.
I think that one was in Dropbox. That was the one thing I saw about like human stuff in your Dropbox.
Okay, hold on, let me try and find this. 2018. Ugh. Well, all right, maybe we're starting. Oh, wait a minute, there's background material. Oh, here we go. Okay. Well, this is something here. I don't know where this came from exactly. I don't know who myself is. So we had a previous effort to connect to Service Connect to Mechanical Turk really long time ago. Anybody know about that?
No, sorry.
That was a thing we had built when Mechanical Turk was young. Wow, 2005.
Service Connect didn't exist in 2005.
Okay, here I've got something 2007. Let's see. It's a whole discussion for 2007. Oh, there's somebody who has an alternative to Mechanical Turk that they were trying to sell me on. Looks like okay, looks like 2009, which is when Wolfram Alpha came out. We had a whole discussion about this. Yeah, I mean, there's hundreds of emails here.
Okay.
But I'm not sure they're relevant. I mean, I think this is I don't know. I think maybe we're better off starting from scratch here.
Yeah, we can do that.
2019, there's all kinds of discussion about this. Okay, now, I mean, we also have a lot of technology in our curation pipeline that I don't know whether this is, I mean, we don't have anybody here representing that, like Alan, for example.
No.
Could we maybe ping Alan, see if he's around?
Yep, I can do that.
Okay. All right, so just so we're clear, I mean, the basic thing here would be some kind of HumanEvaluate that, you know, defines an expression that, now presumably, I mean, what do we expect will be the typical flow here for a human? It's like, here's a question. Well, it's basically the question framework, isn't it? What's the relationship to this?
It really depends on how you feed it back into the system. For the reinforcement learning loop, you are using the human intervention to train an agent that then is used in a reinforcement learning loop. So it's a two-step procedure. Then you have like something like active learning. Well, you have like a model. You're trying to estimate the weak point of the model using the model itself, and then you are asking a human to provide more labels, and then you are feeding in those labels to train the model again and continue the loop. So in that case, the human is in the loop continuously. In the first case, the human is in the loop only at the beginning, unless you want to train a new agent.
Right, but so let's look at our frameworks for doing this stuff. So we have the whole question object framework, right? So in a sense, and this is a new thing that we didn't have when we were talking about this before, we have exactly the mechanism, because question object, we have usually imagined that its objective is we are assessing the human, so to speak, right?
Right.
As opposed to, I mean, by the way, we also have the ask framework.
Right. That's what first came to mind to me, which is very cloud centric, but seems like the right.
I think that's what we want here, because I think the edge of this has to be, you know, maybe it's wrapped inside Mechanical Turk, maybe it's our own system. It's something where, you know, humans are being presented with things. So, I mean, what's the basic idea? The basic idea is somebody would log in, I mean, just like our former kind of volunteer data curator program for Wolfram Alpha, which, by the way, we also might be able to use because we had some technology for that as well. Yeah, we had some technology there that I think is interesting. I think Alan would be the one who would know about that as well.
Okay.
Because that was a thing where you can take a set of tasks. I mean, that's more in the offline way of doing this, of humans rate things and so on. But the basic point is what we are trying to build up is machine generated this, and human generated, and then a human gives a response here. So, I mean, okay, the most naive level, it's kind of like forms, right? But the issue here is there's sort of an outer loop in which we say, these are the things we want to get resolved by humans. Right. I mean,
are you looking for a general, like, I need human input moment in a computation?
Yes. And we're looking for, assume that there's a pool of humans that you have access to. Okay, which and somebody else will take care of, pay the humans, et cetera, et cetera, et cetera.
Okay, but if you say pool and pay, it means like kind of a low effort thing. But could it also be something like this method of ND solve that has been selected, like, is not really working? So do you want to keep it or you want to change it? Like something like kind of expert knowledge. Like, you are looking for something like this as well, or just like low level labeling, like, is this a cat or a dog? Just pick one.
Well, I'm thinking about that. I mean, I'm thinking about I think this is more, this is the thing that, in a sense, the meta point in ChatGPT and so on is there's a lot of information that humans have just put out there on the web that you can forage. But then there's some very high value information about kind of, this is how the AI is going to do something, teach it type thing. And I think what we're looking for here is, an AI has surfaced a bunch of things where it's kind of wondering, humans, please rate this. Am I making sense? Rather than, and you can imagine the loop where the AI is saying, is this better type thing. But I think most of the time, this is not going to be an online, it's going to be an offline process. So, from our point of view, what is the, it's really going to be something which comes back. It's not going to come back instantly. It's not like a computer where you say, here it is, and it's back in milliseconds, right? This could take 2 hours. So, I think it's more like you give some computation, and how does it work? If we have, for example, Cloud Submit, okay? Well, let's look at how Cloud Submit does its thing. So
it's going to be like session submit or local submit. You're like offloading a computation to a cloud machine instead of your local machine.
Right, but in this case, you're offloading to a human to do it, right? And then where do you get the result back? If I say Cloud Submit 2 + 2, what's going to happen here?
You get 4.
No,
oh no, sorry, this is submit. Sorry, you get a task object, so you get to you have to assign it to a variable and then get the result out.
Well, so then we say result received. Okay, so then we say evaluation result. What the heck?
So I think the task was clear out when it was completed. So I think the flow here is that you have to define something to do with the results before actually the whole task is completed. There should be some example of what to do.
Possible keys specified by handler function keys.
Yeah, so you can say, for example, with evaluation result, you say X equal evaluation result or something like that. So in this case, for example, when the task is finished, you get a dialog, and the dialog gets the evaluation result.
Right. I mean, if I say, for example, here.
So the simple one that you were looking for is like cloud evaluate.
No, I know, but that's
okay,
a synchronous thing.
Exactly. I don't know. I don't think this can work because you are in a different kernel. So this where should this
message dialog work?
It sends it directly. I mean, it's a different link. Maybe if they do print, maybe it will print in the message window or something like that.
I have no idea why echo didn't work.
Because this is echoing to my guess, I can't be corrected here, but my guess is that it's echoing on the notebook connected to the remote kernel, which is possibly no notebook, but it has no way to communicate with your notebook.
Okay, but this is coming back to this kernel.
Yeah, that's a good point.
You know, I had this experience trying to get ChatGPT to, I was connecting it. It was kind of amusing. I had a function which echoes from a custom plugin from ChatGPT, and it was sending those echo outputs in totally random places. Like I found one in the messages window, I found one in the notebook I was using. It just sort of sprayed them in different places.
I would expect Echo to put it in the message window in this case.
Well, maybe it did. That's
well, if you do print, it goes to the message window. So I assume echo as well.
All right, so let's try this then.
Yeah. And now you open message.
How do I do that?
Window, the one before, and messages. Yeah, right. Yeah.
That's hopelessly. Well, who knows?
But it was there. It opened on your other screen.
Okay.
If you drag it here, we can see it. So yeah, it is doing something there.
Okay, fine. Okay. Hold on, I can go fetch it just a second here. Well, maybe I can. It's more difficult than you think. Oh yes, there we go. Wow. All right, let's see if I can get this to work. There we go. All right, here's my messages window. Fantastic. Oh, so it
Okay, so you also got the echo. Yeah. Yeah,
it looks like I did. For evaluation results, arrow, whatever it is. Okay, in any case, be that as it may. I mean, asynchronous stuff is hard to deal with here, but you know, so in the case, by the way, did we manage to find Alan or not?
No, not yet. I didn't get a response. Kristen's working on tracking him down.
Okay, so I mean, it's just a little bit unclear how this would work, because, as I say, best case, it will generate a task object where the task environment is human. Do you see what I'm saying?
Yeah.
And then eventually it will be finished. And I mean, so then what would happen is this would, at least conceptually, it'll pop up on somebody's machine and it'll say, do this stuff. And then, so I wonder whether we can trivially do this right now. In other words, the task, this task, somebody would have to check out the task, right? So in other words, there will be a queue of tasks. Okay, so how does it work? Generates a queue of tasks. Person picks a task that they want to do. When they finish, this goes back through the handler, through the event handler. Does that make sense? Does that make sense?
Yeah, I can assume we might have like different like events. For example, the task started, but you also have maybe like when the task was submitted, when the person accepted the task.
Yes.
You would have like
right. Task
time spent into different stages, so you can like do something if it takes too long.
Pending. Task accepted by human, basically.
Yeah.
Task underway by human. Task rejected by human. I'm sure these things exist in the
we
API.
should look at what exactly. We should look at some API that is doing this now.
Right, but from our point of view, the plumbing, okay, and then task completed, and then there's all kinds of things about running checks and so on, but that's less relevant for the AI stuff, I have to say. It's just like the more you have of these, the merrier.
And this, like a task, it doesn't block the kernel. That's what we're saying.
Correct.
Yeah, this is a submit thing.
So you don't. So it's not. You don't use this like in the middle of a code that then's depending on the results.
But if you want, you can do a task wait on it. It's like async await in JavaScript. Yes. You can always make an async code not async by waiting.
Right.
But in the more general case, it's asynchronous.
Right. I think this is. The very beautiful remote batch submit. This allows you, so this is a case where, it feels very similar because, some of these things you're submitting a batch job that might take a day to run.
Yeah.
Now, an interesting question is whether, for Amazon in particular, whether the mechanical Turk credentialing system, authentication system, is the same as this one here. Do you see what I'm saying?
Well, I believe that with Amazon you have one account, but you can have access to different. One account could not have any access to particular service, but I have to check this.
Right, but this here looks very much like remote batch submit. An interesting idea would be, could we just use remote batch submit for human tasks, where the back end is not a computer but a human? See what I'm saying?
Well, I'll have to check exactly what's the difference between the session submit and the remote batch submit. If this just due to some technicality of how this cloud provider works.
There's a huge piece of infrastructure to do with how this remote batch submit works. It allows you to access the job scheduling queues and all that kind of stuff. Do you see what I'm saying?
Yeah, so you're saying that this is strictly more sophisticated than session submit.
Yes, but it's more sophisticated in a way. Look at all this stuff here. Oh God, we're going to have issues with child labor laws if we have all these child jobs.
I was thinking the same thing.
It's different. Okay.
Okay, so do you see this as an interface to some kind of external provider? like that we wrap it in something which makes it convenient to
Well,
use.
probably. I mean, it depends, because I can also imagine, so Alan, we're talking about this HumanEvaluate function, compute, and we're remembering previous, things like the volunteer data curator program,
Right.
for which we built a certain amount of infrastructure, right?
I mean, there's nothing that I think would be useful in the present day. I mean, we
Right, okay,
sent
fine.
people spreadsheets and asked them to send them back in, and we imported things.
Okay, fine. Okay, but so mostly, okay, and the other question is our curation pipeline stuff, which again may not be relevant to this, because it may be that what we're doing here is at a different level. That is that, I mean, I do
Not
think
necessarily. I mean, that
yeah.
was the first thing I was thinking of when I'm trying to digest what I'm seeing on your screen, because I don't know much more about this. But that was the first thing I was wondering if that's going to be useful for this.
Right. Well, I think the main thing here is for reinforcement learning.
Yeah.
Stuff. And the issue is, yeah, I mean, I don't know to what extent this thing is kind of a disembodied thing, as in you just say, here's this thing, is it good or bad? And to what extent it's important to have kind of real-time feedback, saying you're doing a chat, thumbs up, thumbs down at each stage. Because those require somewhat different infrastructure. From a machine learning perspective, is it
typically
clear?
From a machine learning perspective, you want a data, you want a data set, and you let it go for, you have like an amount of answers that you want, and when you have it, you take the data set and you start training.
Yeah. Okay, so you're
so
saying
it is very much offline in using your
right. It's not like the robot
said
is
earlier.
trying to feel its way around the room with reinforcement learning somehow, and or learning to balance a pendulum or something, or learning in a game.
Yeah, exactly. I mean, this was the point of the human in the loop thing. Like, but what it was done, it was they trained the reward model using this, and then they put the reward model into reinforcement learning. So you are using this human feedback to simulate human judgment, a human evaluator.
Yeah, but not in real time, and an
No,
offline way.
no. What is used in real time is that when you have the simulation, you have a model that simulates a human evaluator, then you do the training in real time, the reinforcement learning in real time. But at that point, you're dealing with two machines, not a machine and a human.
Right. But so for us in the reinforcement learning stage, so let's imagine that we've got, we've built a certain amount for this, and I always get confused by what's actually useful or not in this case.
We built a little bit, not too much, honestly. And this is one point. Like, if you want to use this for reinforcement learning, I think we should first design reinforcement learning from like ground up, because
right. But
we had like some
what we had before was kind of crazy. I mean, in my view, because it was
the
very
stuff with
real time.
With the device framework.
Yeah. Yes.
Yep.
It's very real time, which I don't think is really the point here, right? I mean, in other words, what one wants is there is a reward function type thing, which basically just says which is some kind of function that could be obtained from the human feedback system, and then what you're trying to do is training against that function, as opposed to training. I mean, we've had that in the whole active classification thing and so on, active prediction thing, right? That's surely what that is something which is trying to figure out how do you poke at the function. See what I'm saying?
Yeah, I mean, the idea of this is basically that you have a long list of unlabeled data, and you have an oracle function. So here, this #+2 is the function that knows the answer. Then you have a long list of data which you don't have labels for. And the point of active prediction, active classification is like, I should try to code, like imagine that the labeling function is not like something like this, it's more like exactly a human or like an API call. So you want to use it as few times as possible. And
well,
this is the
you
point.
don't really care if you've trained something based on a bunch of human feedback stuff. You've now trained it, and it's now cheap to call that thing many times.
Exactly, and this is why you do that. Yeah.
Right, but so then in this case, what's the difference between so what you would typically want to do is to take an existing model, a net model of some kind, and you want to basically tune it up, right? With is that a fair, reinforcement train of the net model with the training function, with the reward function?
Yeah, but this is generic reinforcement learning. Yeah.
Right, but the question is, what we've done in the past was a very messy thing, which involved, worrying about devices and real-time feedback and this and that and the other. I think what's emerged now is that there is a form of tuning a model, so to speak, that, actually, let's ask a couple of questions.
No, but okay, but the reinforcement learning step is still in real time. Like this is my point from before. Like if we want to use this thing in reinforcement, this is a separate step that basically creates the environment for reinforcement learning.
Well,
so if you want to discuss it,
this is something where this thing would run n iterations and give us back a new net model.
Yeah,
and
exactly.
The fact that it ran, everything is real time. It's a computer. It's computing. It's not.
Yeah, but this has nothing to do with the human part, except that the reward function was created that way.
I understand.
So
I understand. So
if we don't have a good design for reinforcement learning in general, we don't have the good design for this in particular.
That. Right. But so to me, okay, what would fine tuning look like in our framework? Because what we don't have, we certainly have, here's a model. Now go train this model, right? We have that. That's it. If I were to take, net model of, MNIST, of Lynette trained on MNIST data, right? Exactly. I could take that model, happy model, and I could say, let me make, just for fun, let me train it on, I don't know what I can do. I can pictures of cats and dogs or something, or pictures of, let me do this. Let me just make, let me rasterize, let me make A goes to rasterize A, comma, style, sorry, of rasterize style hash, comma, 30, let's say something like this, and let's say that mapped over the alphabet. I've never tried this. What's going to happen? You know what I'm going to try?
Yeah.
Okay, there we go. Net train.
You need to revert this.
Oh, it's the other way around, right? Thank you. Okay. And then net train of this net model here. Boy, this is really nice design. Wow, I never tried it this way. Well, let's see if it does anything.
Well, it should. Oh no, well, because you didn't modify the network. Now you have to basically replace the output with more classes. You have 10 classes and a class decoder that is going from 0 to 10.
All right, so let's just do this.
Exactly. So if you do that, and then
mod 10.
Exactly.
Come on, there we go. Okay.
Now this should work. Yep.
Coolosaurus. Okay. Is it surprising to you that it's going in jumps? Okay, it seems to have learned something.
Well, the error rate is not related. It's not one-to-one to the loss, yeah, because it's a piecewise thing. If it moves to one letter or the other.
Okay, great. Let's take this, and as our test, let's feed it an S here, and let's see what it does.
Well, I mean, hopefully it has learned the training set. It
did.
should try like a different S,
Well,
but yeah.
I know, but let's
Yeah.
try. Okay, let's just try something like rasterize style S, 30, font family, arrow, ACK. I don't know. Let's try this, whatever that is.
Like Times New Roman. Oh, you have raster instead of rasterize.
Okay, let's try that. Blah.
What
Okay.
those three? See, well, you gave one example of everything, and is also squished because it's resized to a square. So, but yeah, I mean, in principle, this is gonna do something. Yeah.
Right. So what we're talking about here is
I think what, or if I can interpret your mind, what you're talking about is a design meeting or reinforcement learning.
Yes, but I'm just trying to understand the basics here. Okay. So if I'm understanding correctly, like active classify here, what we're doing, the difference is that whereas here we are trying to make a prediction function from nothing, in the reinforcement learning case, we are taking an existing model and we're saying, I mean, in the case, in this human feedback case, what we're really going to want to do is basically just this, right? You've done a bunch of human feedback. The only difference is the selection of the questions that are, look, the loop is something like this.
But there's no difference. It's just how we wrote the function. You can start a reinforcement learning loop with an untrained model, and you could have active prediction with an already trained predictor. That's just the initial condition.
Okay, then
it's not an intrinsic difference.
Okay, so let's be very practical. Okay, we've got some LLM, for example. We're trying to do, we're trying to do RLHF for the thing. Okay. So it's going to surface certain things where it wants a human to opine, right? Model surfaces things it wants to ask about.
No, this is, again, we need to keep this separated. The way this was done was that it was already all clear from the beginning. You had the language model generating a bunch of continuation, and you ask the human to rate those continuations. This is step one. Then you take these votes and you create the reward model.
I understand.
And so it's not a model like you say, like
step
generate
one,
a lot of stuff.
Okay, step one, you just said there are a bunch of continuations, rate them, right? What continuations? What are you doing the continuations of?
Well, there you have a prompt repository.
Well, right, but
like
where do you get
instructions. You as an engineer, you define that. Maybe it's a prompt repository that you did for the initial fine with supervised learning.
Yeah, I understand, but okay, so all right, fine. So it's not surfacing things it wants to ask about for itself, so to speak.
No, this is more what active learning is doing. Yeah.
Yes.
Kind of judging the performance, like, or estimating what is like the boundary region. And there's a lot of theory of that.
Like worth asking about, right?
Exactly.
So that's what I'm saying. This is at the point where. Okay, so. Okay, look, the thing about training a reward model. Okay, we kind of understand that's, that is a supervised learning story.
Yeah.
Right. And for that, which is, a fixed set of questions, and you want a human to opine on the results. That's where humans submit.
Yeah, in this case, for example, the question, I mean, in the case that you are thinking about, the question is like you have this initial string, these like 10 way to continue the string, sort them by your preference.
Fine.
And so this is the HumanEvaluate task. And then you get the data set, and you do something, I don't know, like ELO rating to take this training set and make it into a scalar evaluation.
Yeah, fine. That's fine. But then what's the difference between what you do next and you're saying one thing I could do is take that training set. I could, one thing is take the human generated, input output training set, input output set, and train with that. But the other thing to do is train.
Sorry.
The original
train
model.
What?
Okay.
Yeah.
Train the original model. I understand.
And this is what happens. This is like step one, because you do an initial fine tuning.
Right. So that's initial fine tuning. Okay. Then the step 2 is train a model from scratch. Train a reward model from scratch from the input-output pairs.
No,
right?
No, this is the point. You train the reward model from scratch from the data that you collected with the human submit.
I know. That's the input-output
No.
collection. Yes, that's what I mean. Take the human-generated input to output set.
Okay, you do it twice. Okay. This is not for the world. Okay, let me clarify the whole pipeline, because otherwise we look at it in different pieces, and it's never clear. So for the specific case of language models, what you do is you take a language model, you have a repository of prompt, and then you ask humans to continue like those prompts, like tell me this, follow this instruction, answer more nicely, don't say this thing, and then you have the human continuing doing the job of a chatbot, and then so this is the first human interaction. So this is the first human submit. Just continue the prompt as a human, and then you do some supervised training. That's normal training of a language model, like learn to predict the continuation. But now is a human continuation of a specific nature, and this is the first bit. Then you have a second human interaction, which is now you have a model which is better at following instructions because it's seeing examples with the first human interaction, and you have it generating like different possible continuations. Like you ask for a question, you have like 4 answers, and then the second human interaction is rate, sort according to your preference these 4 answers, and on that sorting you train the reward model that is in turn put into the last step, which is reinforcement learning. So we have 2 calls of HumanEvaluate, let's say, in this.
Right, fine. But the reinforcement learning part is a part that is like our active prediction, but slightly differently packaged.
Yeah, because active prediction is looking at specific inputs where there's some external model is estimating that you need to improve.
I know. Where you were given these things here, right?
Yeah, exactly. So you have this unlabeled thing, and you need to know when to label them. In this case, for reinforcement learning, it's typically not expensive to call the environment. It's called like the Oracle function here is called typically environment, because you have the agent that interacts. It's like the nomenclature is from robots interacting with the outside world. So the reward model here is the environment, and the robot is the language model. But I think we are looking at this too closely to this specific problem. But
I understand what I'm trying to understand. There's a final, reinforcement train or something, reinforcement learn, whatever it is, which takes a model. It takes 2 models: the model to train and the reward model. And what's
Yeah.
going to happen is it's going to start selecting different possible cases, and it's going to then, see what this model goes input to output, and then the reward model runs on that. And, then it has to adjust this model. And the output here should be a, improved model, right? Correct?
Yeah. I mean, like, it depends on what, I mean, there are several techniques for reinforcement learning. I think that the one used, okay.
Right, but I mean, the issue is, one of the questions is, which samples do you take? In this case, this thing should be figuring out which samples are worth taking.
No. This is not typically what's happening. Like, what's happening is that that you still have your prompt repository, but in this case, differently from the typical training, you're not getting an answer token by token. Yeah, like in the first supervised learning or in the unsupervised thing, because you want it to finish. Yeah. So you take your prompt repository, you let your model go and generate like a bunch of continuations from, like, 10 prompts, 10 continuation. And this is all like hyperparameters. This is the reason why it's so finicky, reinforcement learning. And then you unleash your reward model and say, I think you did well. I think you did not well. And then you feed the score into this. And then the loss function of the model takes into account the score.
Right. But the whole point is you're doing it on the whole output. In the LLM case, perhaps different from some other cases, like, I don't know what you do in the robot case. Right?
That can also be, because it depends. Like, if your robot needs to, like, put a ball into a basket, it doesn't matter where it is in between. Yeah, you only can give like a well done when the ball is into the basket. Right. Or you could have a different regime where you wanted to take the shortest possible route. So you have like a penalization if
it's playing some video game and it tries to see whether it can do the whole game and win.
Exactly. Of course, I mean, if it is too long, you have stability problems, because, like, I know if I just tell you, like, well done when you win a chess game, it's very difficult to understand what was correct and wrong in the middle.
But the fundamental point here is this model to train has certain, I mean, it's not a single token at a time. It's the folded version of that, the nested version of that's going to generate the whole output.
Exactly. Is run it and then I let me read it. Okay, I like it, I don't like it.
Well, the question is here for this reinforcement learn function, we have to figure out, what are the levers that it has on the model to train that it can change, right? And that's where all these different techniques for reinforcement learning come in.
Exactly, like PPO, or like you have like the Q-value based. I mean, there's a off policy, on policy, there's big families.
What is the typical for our case? Okay, let's say we were using this model, some very simple model here. What levers would be, and let's imagine that our full thing is reading a whole word or something, or reading a whole number. And I don't know, we have some loss function that's based on, I don't know exactly what it would be, but where it's this, like for example, let's imagine that our whole function was just something like map this over, a list.
And then, a list of letters, and then you hear the letters, you join them into a word, and then you have to say, is this the right word or not? Something like that. Yeah.
Yeah, that's good. That's a good example. Yeah. So let's imagine that this was letters, and then we say string join of that, and then we say dictionary lookup. Dictionary word queue of that.
Okay, this is a discrete reward, so it's difficult to take the gradient of this.
Okay.
But
Fine. So it's like, I don't know how we do that. How close to a, how close to a dictionary word is this? Okay, so now what do we do?
For example, you can. I mean, typically, what you want is that you want to
So
like give an
what
estimation
are the
about
levers? What are the levers that given that we've got this thing, we've got this loss function, what are the levers how do we know what levers we can pull here?
like what are the hyperparameters
parameters
of a specific reinforcement learning model that you're using?
No, I understand, but in the end, you want to modify this net model. That the end goal is to modify that net model, right? So I'm just asking, how would we get inside the net model to be able to modify it, given that we have, essentially what we've got here, more accurately, is, function of the underlying model, right? And what we're trying to do is to train the underlying model based on the reward model applied to the function of the underlying model. Is that right?
Well, I mean, the reward model is used in computing the loss. So basically, what you have is that you apply the underlying model to your thingy. This is generating, in this case, probabilities of letters for each, and then let's say, very broadly speaking, you try to assign like a value.
No, look, you've got some function of the underlying model that's applied to this function of the underlying model is being applied to data at every step. Right? In the case of an LLM, it's, keep running until you get to a stop token.
Yes. Okay.
Okay. And then the whole point is that what's different here is that you are applying this reward model to the whole thing that was generated.
Yes.
Not to the individual steps of the underlying model. Right?
Yes, in this case, yes.
I'm going to claim it's kind of almost the general case. I mean, like you're playing a game, there's a thing that, takes a step, an individual, turn in the game. And then there's the whole picture, which is how you're going to win or lose. And then
yeah, but like, for example, stuff like AlphaZero, like the reward model is more like that you are trying to estimate your probability of winning at every move.
Okay. But I think in the end, this is, but the way you're doing that, I mean, in the end, you're going to win or you're going to lose, but that's the result of a whole series of things, whole series of steps.
Yeah, I mean, to be more precise than that, I will need to like refresh my knowledge on this. So I don't want to get too detailed and possibly say wrong things.
I strongly suspect this is right, because I've been quite confused about, what the minimal way to state all this is. I suspect this is it. And then the thing which is not obvious is, how do you dig inside that function to go and make modifications to this thing that's inside, given that all you're actually seeing, in other words, so yeah, I mean, but this is the standard problem of, how do you update? It's like you've got a big neural net with many layers. How do you update individual parts of that? I suspect this is correct, but coming back to, and this will be a very useful thing for us to clarify how this works, right? Because I suspect this outside function, unlike the functions that we already have built into layers in a neural net, right, where we know how to differentiate them and all that kind of thing. The confusing thing here is that outer loop function is not as obviously, we don't have that in that same framework. So I'm saying, so that's why it looks different and more challenging to do learning against it, so to speak. I am going to need to go in a second here, but back to the human compute thing for a second. I think what's becoming clear is that the fundamental operation is you submit a bunch of expressions that could be questions, and you basically want people to provide a mapping from expressions to results. And that mapping could be framed in terms of the expressions being questions and the results being what they would do in question answers that would then be fed to an assessment function. Or it could be anything. I mean, it could be like, Like, what's the first word that comes to mind given this particular thing? It's just some mapping from inputs to outputs defined by humans. And then the workflow we have to figure out is just how do we present those as jobs in Mechanical Turk or some other system? Does that make sense?
Roughly speaking, yes. It's more like, it's very similar to some like controls we have. It's like a picker, like a text field, depending on what you're asking. Yeah, if you're asking
right, but
to
that's what
type something in,
framework,
to select something.
The question framework exactly deals with that issue, as to some extent does our form framework. See what I'm saying?
Yeah.
In other words, the issue here is more the question of how do you present it to whom, who picks the jobs, out of the queue, et cetera, et cetera, et cetera. How does that all work? Which is where the whole framework for, and I think if we can do that, we now have, we need this additional kind of thinking for this. I really do think this line is kind of the summary of what's going on. But anyway, so, I think what we should do for the human submit thing, if we think it's worthwhile, which I think it is understand what these different, platforms are and whether it's easy to make a service connect, whether, for example, in the case of the Amazon one, the remote batch submit thing, which already works well on AWS, could almost directly be used for that. And I was not expecting that this discussion would take the whole of our time here, but it has. So I think we have to wrap up here.
Should I schedule a follow-up meeting specifically for this? Like a shoot-off type meeting?
Probably. I mean, I don't know what the priority of this is right now. I think it's worth, we got a lot of other things going on.
Right.
We may need this for some of the machine learning projects we're doing, in which case we better have built it, if we need it. So I think it will be worth, yes, it will be worth a little bit of assessment of how hard is this to build.
Yeah, okay.
And maybe Jesse, who worked on remote batch submit, might know the answer to that from that side. And
for human submit, most of the work is like non-machine learning related because it's like interfacing with something.
I think so. Yeah, I think that's correct. I don't think it's for your team. I think it's for the service connection team, probably. Okay, and they may already have stuff that was done, because I know we did do stuff years ago on this. So let's try to find that. And yeah, the part for the machine learning team is more this reinforcement learn type functionality, which I claim is not as scary and undefined as it looked before. I mean, what do we have? I need to go, but we have some stuff, right, for this is such a horrifyingly not the point thing, I think. What is this? Where's the... Okay, these are the states, but where is the actual learning?
No, there's no learning here. This is just an environment.
Okay, but how do we use this environment?
Well, basically, this is to generate the is the Oracle function.
Yeah, I understand.
Or
how do we use
function.
that Oracle function? What function are we using? We're using it inside active.
No, inside NetRain. Inside NetRain. Let me find the. If you search reinforcement learning, you should probably. Okay. OpenAI Gym has should hopefully some example. Okay, now this is just a link. 1 second.
Great, there are the video games.
That might have been an example. I have to check because this was done years ago, but might have been just an example in marketing pages. when this was released about how to use this. But yeah, let me check that and
Okay,
follow
all right,
back.
fine. But then I'm claiming that this is the kind of thing we eventually need for various functions here.
Yeah, I
And
mean, we have
those
several design proposals. So like if we have a follow-up meeting, I'll bring up what Jerome did about this stuff like last year, and
Okay,
yeah, the stuff we have to look at in that case.
Okay, but I think it's going to be for some particular functions here we can make this work. And okay, sounds good. All right, see you guys soon. Bye.